Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, in the previous class, we have been discussing about the contact and non-contact forces. We have already discussed about three types of contact force. There are two more types of contact force which I have not discussed in the previous class. Today, we will be discussing those two types and also talk about the non-contact forces. Okay, so talking of the various contact forces, we have discussed three contact forces. One was the frictional force, second one was the normal reaction force, and the third one was the tension force. Today, so the fourth kind of force, so just let me make the heading contact forces. We have been discussing contact forces. Okay, so the fourth kind of contact force that exists is the spring force. So what is the spring force? You see, whenever you stretch a spring, okay, or compress a spring, it has a natural tendency to move back to its original position. You stretch a spring, what happens? It seems that as if the string is exerting a force in the opposite direction in which you are stretching the string. So this kind of force that the spring that develops in the spring to take back the spring to the normal position is called restoring force. So when we are talking of spring force, remember the spring generates a force opposite to the direction of the external applied force, and that kind of force is called the restoring force. Okay, now this restoring force that develops in the spring to take the spring back to its original direction can be regarded as the spring force. Okay, so basically, and this value of the spring force or the restoring force is actually directly proportional to the amount of stretch or amount of compression that has been imposed on the spring. So remember this thing, this restoring force, the more you stretch the spring, more is the restoring force developed. So the restoring force is actually directly proportional. So we can write restoring force directly proportional to either the amount of, you can say, amount of extension or the amount of compression. So both the amount of compression or the amount of extension causes the restoring force to vary. The more you stretch the spring, more is the contact force, the spring force that develops. Okay, and the more the compression you create on the spring, more is the spring force developed. So this is the fourth kind of contact force. Now the fifth kind of contact force that exists is the collision force. You know what is collision? When two bodies collide with each other, a force is exerted on the two objects. Okay, one body exerts force on the other body. Okay, fine. Okay, so collision force exists only when two bodies collide. Now just think of the fact that when two bodies collide, what happens? One body exerts certain force on the other body. Okay, suppose say body A is moving in this direction and body B is moving in this direction, opposite to each other. Now at a certain instant of time they will collide with each other, isn't it? Now when they collide, the body A exerts a certain amount of force on body B, as well as the body B exerts certain kind of force on body A. Both the forces are equal. So the force exerted by the body A on body B, if it is regarded as the action force, then the force exerted by the body B on body A can be regarded as the reaction force. Okay, so here action and reaction force exists. We will be discussing about this action and reaction force when we will be talking about the Newton's laws of motion. Okay, we will be discussing about the action and reaction force in the third law of motion. Okay, so this kind of force which exists when two bodies collide with each other can be regarded as the collision force. Okay, or the force exerted due to collision. Okay, fine. Now, so these are the 5 kinds of forces that exist when two bodies come in contact. Fine. Now we will be talking of the non-contact force. We have discussed these non-contact forces to a certain extent when we have discussed about the forces that exist in nature. Okay, so we will just again recapitulating those concepts. So non-contact force. Non-contact force. What are the non-contact force? Okay, see, the non-contact forces are mainly of three kind. Okay, first of all, the non-contact force that we feel or experience the most is the gravitational force. Okay, gravitational force. Okay, so what is this gravitational force? We have already discussed while we were discussing the forces in nature. We know that each and every body has certain kind of mass, and due to this property, inherent property of mass, each and every body in the universe exerts certain kind of force on the other body. So this force which a body exerts on another body due to its mass is regarded as the gravitational force. And we will be discussing about this gravitational force in the later part of this chapter, so we are not going into any details. Okay, second kind of force that comes into play is the electrostatic force. So second kind of non-contact force, that is electrostatic force. Okay, so electrostatic force. What is electrostatic force? See, we know that each and every body has certain amount of charge in it. Why? Because you know that every body or every matter is composed of atoms, and as you know, atoms have electrons, protons and neutrons in them. Definitely this matter as a whole has certain amount of charge in it. It may be such, the situation may be such that the amount of positive and negative charge may be equal, and for that reason they may be appearing to be neutral, but they do consist of certain amount of charge. Now, when there is an unbalanced charge in a body, unbalanced charge, that is there is a certain kind of positive or negative charge in excess, then that charge can also exert certain kind of force, and this force is regarded as the electrostatic force. Okay, so electrostatic force is basically the force exerted due to the presence of charge, as was the gravitational force. Gravitational force, as you know, was exerted due to the presence of mass. Similarly, electrostatic force is exerted due to the presence of the charge. Now, gravitational force, if you can think of, it will be actually only attractive in nature, whereas electrostatic force can be both attractive as well as repulsive in nature. When opposite kinds of charges come into interaction, the force developed is attractive in nature. When same kind of charges come into interaction, the force developed is actually repulsive in nature. Okay, so electrostatic force can be of two kinds, attractive as well as repulsive. Okay, so this is electrostatic force. And the third kind of force that is of non-contact in nature, it is magnetic force. Okay, magnetic force. This is also non-contact force, because you have seen that a magnet can attract an iron object even though the iron object may not be in contact with the iron object. The magnet can easily attract that iron object from a certain distance also. So obviously this is a kind of non-contact force. So magnetic forces actually exist due to the property of magnetism. Some materials are magnetic in nature, they are called magnets, and they do show the property of magnetism. Okay, the magnetic force can also be like electrostatic force, be of two kinds. It can be attractive in nature, it can be also repulsive in nature. You know that a magnet has two poles, north pole and south pole. If two opposite poles of magnet come into interaction, the force will be attractive in nature, and if two like poles of magnets come into interaction, then the force will be repulsive in nature. So this is the nature of magnetic force. Now, okay, so these are the three kinds of non-contact force. Now, just to end the class, we will be talking about some general characteristics of the non-contact forces. All these kinds of non-contact force, either gravitational, electrostatic or magnetic, have a certain common characteristic among them. What is that characteristic? Let us see. See, all these kinds of non-contact force, if you have noticed, depends on the distance between the interacting bodies. You see, if a magnet is placed close to an iron object, the force with which the iron object is being attracted by the magnet will be different when the object is placed at a larger distance from the magnet. And you have seen that with more spacing between the magnet and iron object, the magnetic force being exerted decreases. So this is one property which is seen also in case of gravitational force and also in case of electrostatic force also. So this law is called the inverse squared law. This law is called the inverse squared law. Okay, for magnetic force, for electrostatic force as well as gravitational force, okay, the amount of force exerted decreases inversely or is rated inversely to the square of the distance. Okay, so first point is that these non-contact forces decrease with increase in distance between the two interacting bodies. So this can be stated as, that is, the force is inversely proportional. If we try to remember the exact mathematical relation, it states that the magnitude of this forces varies inversely as the square of the distance of separation. Okay, so the magnitude of these forces means these three kind of non-contact force. Okay, what happens? Varies inversely with square of distance. This is the important point that you must remember. So with increasing distance, the value of the magnetic force, gravitational force or the electrostatic force becomes less. Okay, so this is the first common characteristic that all the forces, non-contact forces, have in between them. And the second characteristic I have already discussed, that the gravitational force denoted by, let us say, Fg, and electrostatic force, gravitational force alone is having only attractive nature. Okay, attractive nature, whereas the magnetic force or the electrostatic force is having attractive as well as repulsive nature. So this is the second characteristics. Okay, if you can see not, okay, now it is visible, fine. So with this we come to the conclusion of this class. We have completed the first part of this chapter. In the next class we will be starting about the laws of motion. Till then, please do study well. If you have any doubt, mention in the comment box. We will be happy to solve the problem. Thank you. Goodbye.